Here we are on day 3 of the BSI Showcase Days being held at the IEC GM in Edinburgh, and we are focusing on quantum. Quantum technology represents a paradigm shift that is going to affect all industries from finance, healthcare, energy, security and defence. And we're delighted that today we're joined by a group of experts who can tell us more about all of those areas, including Lord Patrick Vallance, who is Minister of State for Science.
Global digital standards help drive, as we've already heard, innovation and economic growth. They accelerate commercialisation and lower barrier to international markets by driving down cost of fabrication and standardisation of components.
Specifically, the mission aims to achieve within 10 years quantum computers, that are located in the UK, capable of performing 1 trillion quantum operations.
We need to know how to connect with people who can do those things for us. So whether it's your car that you're driving, 1 or 2, maybe 3 pedals, a steering wheel, we need to know what quantum can do for us and why it's different or why it offers us more advantage for other systems.
We're still trying to develop the technology to be able to be powerful and powerful enough to be able to really start to eat into some of these real life use cases, sort of chemical modelling or the airline industry or anything else for that matter. Until it gets to that point, then these are effectively just test systems, research systems.
The relevance of standards in this space is to actually bring all the experts together so that we can develop best practice, guidance and information that people can use so that we can have the best possible implementation and success rate in each of those areas.
And for quantum technologies in particular, it's useful for the community to find a common language, find the terms and definitions that everybody can agree on. And when we have that foundation, you can start building new standards as the research progresses.
I think we can really believe in that quantum technologies will drive so much process in areas like climate modeling, sustainability, AI and machine learning, optimization of complex systems, and quantum sensing for precision measurements. And as an aspiring scientist, I'm so excited to be part of this development, and I'm so happy to contribute something to that. And we with Girls in Quantum, we really want to prepare the young generation for that.
I start with particles and elements. I heard from friends that there are more particles in a grain of sand than there are sands in the universe. And so my understanding is that the way chemical interactions work is the manipulation of particles from one state to another. With quantum technology, we can slow down the transfer of states, and in that process of slowing them down, we can make them do entirely different things and fundamentally act in different ways.
The main role that MPL takes in supporting innovation in the quantum field is by working with hundreds of firms across the UK to help them innovate, because it's their ideas and their entrepreneurship that is going to create the future markets and opportunities for quantum technologies.
And this is the advantage, the quantum advantage of quantum key distribution, that then no algorithmic advances, no hardware evolution can break the security in a better way than we have today.
We will eventually get quantum memories to a practical state, and we can have quantum transduction, distribution of quantum entanglement and quantum teleportation, and at that point we'll be able to have distributed quantum computing and a host of both security and computational applications.
We have to think about the device as a whole and where it's likely to be most insecure. So a device will have these quantum channels, which are the interesting bit from the physicist side of things, but it also has a classical communication channel, it has various user interfaces, it has a box. So there are various other things that have to be considered as part of the evaluation process.
As we stand on the cusp of this new era, Scotland is well positioned to play a leading role in shaping the future of quantum technology, thanks to a combination of our world-class research and academia, collaborative ecosystems and visionary investment.
So the whole purpose of standards is to enable global adoption and to ensure that actually we have one best practice way of operating. And what you want is for people to be able to be confident that the innovation that they're using is secure, is safe, isn't going to put either themselves or their families or their customers in any form of risk. And that's what standards do. And I think it's really important that when you have global standards that you get the best people together, that you're able to create the best standards and actually then enable adoption of innovation as it rolls out into society.
Sometimes standards and innovation are opposed. And some people always talk about, well, when we are doing novel research, we can't standardize because that is something that comes later. So I think that's maybe a little bit of a misunderstanding because I don't see those two areas as contradictory. They can go hand in hand. And sometimes innovation can actually be emphasized or pushed forward by coupling standardization effort to it.
So the second application I'm really excited about is the logistical application. And a good example of this is if you can imagine that, say on Citymapper, you were trying to get from point A to point B, and Citymapper will work out what the best route is for you, the most efficient route for you from point A to point B, and it will tell you by train, by bus, etc., etc. Right now, that's really difficult to do for multiple people at the same time to multiple different destinations. With quantum computing, one of the applications from a logistics point of view is that 100 people at the same time together could be trying to get to 100 different places, and it will work out the different scenarios through all the different paths of transportation to get us all to the right place at the right time really efficiently and really quickly.
Well, international standards are absolutely indispensable in terms of being able to actually trade your goods. If you don't have international standards, you can't cross international boundaries, and therefore commercialization of these products and services will never happen.
And one of these documents describes how 7 days of GNSS denial would cost the UK economy about £7.6 billion.
We would have a comparison in NMI community, we would have very good coherence in the measurements. They would fall within an agreement of the different uncertainties that each institute would present.
You have the picture on the left. If you have a gravity sensor on top of a volcano and you have magma rising up through the chamber, it will make a measurable signal on the top. And you can measure this, you can compare with other sensors and try and evaluate how much magma you have in there.
To support a vision to develop Scotland's quantum sector and develop that into £1 billion opportunity for Scotland by 2030.
So what I want to see is all of us collaborating across borders and actually having a skills policy that works.
But we don't do that alone. We do that by partnering. So we partner with many universities, we work alongside industry, and we work with people like BSI on the establishment of standards.
To stay ahead of the game and how to make excellent measurements, we needed the tricks of quantum mechanics.
And I think that's my answer to a question that was posed at the start of the day. Was it our moderator, or it might have been Sam, asked us, when will we know when we have been quantumed?
Yeah, we with Girls in Quantum, we really want to prepare the young generation to be creative, to be good in problem solving, to have a strong drive to work hard and really drive this process forward so that we become really good scientists and so that quantum technology can do all the wonderful things that we want them to do.
The UK is investing an extraordinary amount of money in the National Quantum Programme, which is enabling development across all fields, from quantum communications through to quantum sensors. So there is a large amount of investment across academia, industry and government organisations, which is creating a real groundswell of capability, which is world class.
I mean, this is a novel area. So many things are going on. It's on the forefront of research and innovation. So I mean, this caters for international collaboration. Countries and researchers can't do this alone. And by nature, research is international, so it's only natural that we work together in order to achieve common goals in quantum technology.
The journey we're on is not just about technology advancement, it's about creating a framework for that advancement to thrive. One built on the foundation of robust forward-thinking standards Let's make standards less scary. And as Maria said in the last panel we had, together we have the opportunity to shape a future that benefits everyone. And I believe that with the hindsight shared today, we're well on our way.